All right, so let's just do a short presentation on just the reminders and refreshers for how to solve triangles. And what I'll also do is I will send you a link to this PowerPoint presentation that you can download if you want to use it for reference for upcoming tests. Okay. So just again, what we talked about last week as far as the basics of trigonometry in a right angle triangle, we talked about how the angles are relative to the ratios of the sides. So any unknown side or angle can be solved if we already know three things about a triangle: two sides and one angle, or one side and two angles. So in this right angle triangle that we see here, the ratio of the two sides, the 12 and the 14, right? Those are two sides. So their ratio will determine the angle. So they're relative completely. This is what makes, once we get the basics of trig in our head, we just have to know where to plug things in a formula. So on the bottom here, I've just given you a demonstration. What we just said is true. We have two pieces of information here. We have 12 units and we have 14 units. When you put these in ratio form, according to the trig formulas, it equals in this case, 12 divided by 14 equals the tangent of angle A. Don't worry, what does sine mean? What does cosine mean? What does tangent mean? Don't worry about that. We don't need an explanation of what those terms mean. We just need to identify that when we're talking about the sine of an angle, what we need to know about that is that the sine of an angle is based on two sides, and those two sides are different than the two sides of cosine of an angle, and those two sides are different than the tangent of an angle, and we'll talk a little bit more about that in just a minute. So that was how the ratio of two sides can give us the size of an angle. And now in a right angle triangle, the angles of a triangle determine the ratio of the two sides. So here we've got x and y. If we know one of those two pieces of information at least, regardless, x divided by y equals the tangent of 42 degrees. So in this case, we know the angle. The angle will help us to figure out the information about those sides. So just remember that angles and an angle and two sides are always used to solve unknown information about one of those three things. Okay, here's a good example here of how angles and sides are how they're connected, how one controls another. So as one side changes in length, and we talked about this last week, the associated angle is affected. So for example, as side y increases in height or in length, the adjacent angle, so it was currently angle 42, the y length is adjacent or next to angle 42. But as y lengthens, that adjacent angle changes size, right? It begins to get smaller. And the closer or the smaller or shorter the length of y gets, the steeper that, or sorry, the shallower that angle 42 will get. It'll start to get smaller, or sorry, larger and larger and larger until you get to your 180 degrees, if you can ever get there. Okay, so if you notice here that in the initial formula, when we're talking about the tangent of 42, in tangent we know that tangent of an angle is equal to the ratio of opposite divided by adjacent. So in the first formula there, we see that x divided by y equals the tangent of 42. But as y gets taller, x divided by y now equals the tangent of 31. So the angle will continue. Remember, let's just go back to geometry. The equal sign is everything. So it only makes sense that if y changes, or for that matter, if x changes, the angle has to change because this equal sign has to remain true. So if you change one side of that equal sign, the other side changes, or you have to change it. And that's what we're talking about when angles control sides and sides control angles. We're saying that the tangent of 31 degrees is equal to x divided by y. The layout of the formula is the same here. Tangent of 42 degrees is also equal to x divided by y. But what's the difference? The difference is the angle itself. So that should automatically tell you that x and y in this ratio are not the same as x and y in this ratio, or at least one of the two is not the same, right? Because this angle is different than this angle. Just again, a reminder with regards to hypotenuse. I think it was you, Ryan, that mentioned last week about hypotenuse. Now we were talking about an angle that was in the same place, right? In this upper section of the triangle. The hypotenuse technically is adjacent to this angle up here. However, the hypotenuse is always the longest side. So it will never be the adjacent side. Even though it runs adjacent to this angle, because it's the longest side, hypotenuse overrules adjacent. So when you look at a right angle triangle, you're always going to know two things for absolute sure: where the right angle is and where the hypotenuse is. So that's a good place for us to start. Now last week I did try and explain about, when trying to figure out what trig function to use, we have to determine what is the angle we're trying to solve, or what is the angle that we need to use. So the angle that is being solved, or the angle that is being used to solve a side, is called the reference angle. Okay, so the 90-degree angle is not our reference angle. Either this angle 42, where it's positioned, so this angle up here at the top will be the reference angle, or this angle at the bottom will be the reference angle. Okay, so you're always going to know what your reference angle is because it will be identified on the print, or it'll be the answer to your question, right? It may say solve angle 1. That is your reference angle. Or it may say, like in this case, solve the opposite side. So if we need to solve it, it may just say solve x. This may just have an x here, solve x. Well, to solve x, we have to know where the reference angle is. Is there an angle here, or is there an angle here? Because wherever the angle is, that's the reference angle. So in this particular case, 42 degrees is the reference angle. Therefore, the side across from it, or opposite of it, is the opposite side. So this is our reference angle. This is the opposite side because it's opposite the 42 degrees. This length is our adjacent side because it is next to, or runs alongside, the reference angle. So the side is determined by the angle. This side is adjacent to our reference angle. This side over here was opposite to our reference angle. Okay. Another good thing to remember is that the hypotenuse never changes. As we said before, it's always the longest side. But the opposite and the adjacent sides can switch positions. So in this example here, 39 degrees is our reference angle. Therefore, the opposite side you can see is identified. It is across the other side of the triangle. On this slide, now this is the opposite side because the reference angle is in the top corner. So opposite and adjacent can switch locations according to the reference angle. The reference angle tells you where the opposite is, and it tells you where the adjacent is. Okay, I think, Ryan, you were the one that laughed last week when you saw this acronym for the first time. And it is kind of a silly one because it doesn't really have any meaning, but it's just a way for us to remember the 9 letters. Okay, SOHCAHTOA. This acronym, it helps us remember the 3 common trigonometric functions. So the first 3 letters, SOH, means sine of the angle. So the S means sine of the angle, equals, the O means opposite side, divided by the H, which means hypotenuse. So that SOH is your formula. Sine of an angle equals opposite divided by hypotenuse. Cosine of the angle equals adjacent divided by hypotenuse. And tangent of the angle equals opposite side divided by adjacent side. So in this little chart I have below, in those formulas, so that acronym SOHCAHTOA, sine, cosine, and tangent of the angle, that's the reference angle. The reference angle belongs in that location. So if you know the angle, if the reference angle is, let's say, like in our last slide, it was 42 degrees up here in the top corner of the triangle. Okay, so if this was 42 degrees, that's our reference angle. No matter which trig function we're using, that's our reference angle. So that will help us determine what the other sides are called. So if the 42 degrees is up here in the top corner, then this is no longer the adjacent side. This is now the opposite side. If the reference angle is here in this bottom right corner, then this is the opposite side and this is the adjacent side. So it's based on our reference angle. And you can see here that the ratio, which we talked about weeks ago, is just division, right? It's a ratio is the comparison of 2 like things. So these are 2 sides of a triangle. So they are 2 like things. This is one side of the same triangle as this is one side of that same triangle. So we can write them up as a ratio. Okay. So which ratio, which trig function do we need to consider? So let's do an example here. If I wanted to know what angle 1 equaled, if I needed to solve angle 1, then I have to use one of the 3 trig formulas to solve it. But which one? Well, how do I know which one? So I would have to use the trig function that has all 3 pieces of the information that are in the diagram. So if I have a question given to me in my math book, the first thing I want to try and identify is the reference angle. So I'm either trying to solve it or I'm using it in my equation. So I've already told you, in this case, I want to know what angle 1 is. So that tells you that that is your reference angle. So now I have 1 piece of information. Now I need 2 more pieces of information. I need to know 2 of the sides of this triangle. So if I'm not given 2 sides, if all I have here is the word hypotenuse and all I have here is the word opposite, I can't solve this triangle. Because in any trig solution, you have to know 3 pieces of information. In this case, I know this is 90 degrees. So there's 1 piece of information. Here's a length of a side, and here's a length of a side. So I now know 3 pieces of information. So in trig in general, you have to have 3 known pieces, 2 sides and an angle, or 2 angles if we had another angle here, and 1 side. So in this case, we have an angle and 2 sides. So we can solve everything else about this triangle. The 2 other angles and the other side can all be solved. So in this case, all I want to do is solve angle 1. So I also need 3 pieces of information. One of them is an unknown, but that's one of the 3 pieces of information. The unknown is our reference angle. I don't know its value, but I need to solve it. So what do I know? I know this side that is adjacent to this angle. And I know this side, which is opposite to this angle. So all I have to do now is I need to pick one of the 3 trig formulas that has an opposite in the ratio and an adjacent in the ratio. That's it. There's nothing to this. Just find the one of the three trig formulas that has adjacent and opposite. So which is that? Well, obviously it's tangent. If we look at our SOHCAHTOA, sine is opposite in hypotenuse. Well, I don't know the hypotenuse, so I can't use sine. Cosine is adjacent divided by hypotenuse. Again, I don't know hypotenuse, okay, and I'm not trying to solve hypotenuse, right? So I won't use that one. But tangent has opposite and adjacent. I have two of the three pieces of information. As long as I have two of them, I can solve the rest, right? So tangent of angle 1 is equal to opposite over adjacent, right? Does that make sense so far?
Yeah, it is.
Okay. So here's something interesting, and this is what, I love math. I love how everything just it's perfect with math. It all fits together. So in this exact same triangle, we just determined that if I want to know the angle of angle 1, I want to know its value, then I will use the trig function tangent, because tangent of that angle is equal to 6 divided by 4. Opposite divided by adjacent. Make sure the numbers go in the right place. Okay, tan of the angle equals opposite 6 divided by adjacent 4. But if I wanted to solve angle 2, I can use tan. And I can use tan because opposite and adjacent are still in that triangle. They're just swapped. So tangent of angle 2 equals opposite 4 divided by adjacent 6. So depending on what, now you can see that if I have three pieces of information in a triangle, I can solve the whole rest of the triangle. I can solve angle 1 with the trig function tan of angle 1 equals 6 divided by 4. Angle 1 is solved. Angle 2 is tan of angle 2 equals 4 divided by 6. Angle 2 is solved. I now know all three angles of that triangle, and I know two sides. And to solve the last side, I can either use trig, or I can use the Pythagorean theorem, right? A squared plus b squared equals c squared, which is your hypotenuse. So it is, we don't want to work too hard to find what we're looking for, right? Look for, number 1, your reference angle. Once you know it, what sides do I have? And those sides will tell you which trig function to use, okay? Let's just go, we only have a couple slides left here. So I just demonstrated what we just talked about. Tangent of angle 1 is 6 divided by 4. Tangent of angle 2 is 4 divided by 6. So if you solve those two angles, right, and as a matter of fact, just for the sake of doing this, 6 divided by 4, second function, 6 divided by 4, second function tan. Okay, so 56.31 degrees, all right, is angle 1. So let's just round it, 56 degrees, okay? And 4 divided by 6, second function tan, is 33.69 degrees. So if you add those two angles together, plus 90 degrees, you get 180. So it's a good way to cross-check your work, right? To verify that you solved your angles right is that solve the two angles, add it to 90, and if you don't get 180, then you've done something wrong. I think Matthew mentioned this last week, so I'm just going to show you this, but we're not going to go into detail about this right now. This will be for future math courses. So we have enough to do with the three main trig functions. So sine of angle A equals opposite over hypotenuse. The cosine of angle A is adjacent over hypotenuse, and the tangent of angle A is opposite over adjacent. But we also have, oh, it looks like it did some bad spacing here, but we also have the reciprocal functions, not the inverse, the reciprocal. Okay, so the definition of reciprocal is equality. So what the reciprocal here is, in this case, if sine of angle A is opposite divided by hypotenuse, its reciprocal would be cosecant of angle A equals hypotenuse over opposite. So they just switch places, right? We would put hypotenuse becomes the numerator, opposite becomes the denominator. Likewise down here, right? Cosine of angle A is adjacent divided by hypotenuse. Its reciprocal is secant of angle A equals hypotenuse over adjacent. And then finally, tangent angle A is opposite divided by adjacent. Its reciprocal is cotangent angle A is adjacent over hypotenuse. So I just gave you a little demonstration, a picture, right? The blue right angle triangle is the reciprocal of the red right angle triangle. And they are equals in the world of opposites. Right? So you can see that sine of 30 is the reciprocal of the cosecant of 30. And in geometry, does this ring any bells in geometry? Notice this is one continuous line, and this is a line that crosses it. The intersecting angles, or the interior angles, or what do we call them? The opposite angles are the same. So if they're the same in geometry, then they are the same in trigonometry. They are the reciprocal of one another. So I don't want to go into any more detail about the reciprocals because we need to focus on the basics of trig right now, and we can go into those reciprocals hopefully in a future time. So let's just take this example here. In this triangle, the opposite side has to be solved. So to do so, we have to know at least three features of the triangle, right? Of any triangle in trig, we need to know a side and two angles, or two angles, or two sides and one angle. So what do we know about this triangle? Well, we know the reference angle is 30 degrees. We know that there's a 90-degree angle in that triangle as well. And we also know the length of the hypotenuse. So now we know three things about this triangle. Though having knowing three things about this triangle will allow us to solve the rest. So therefore we can solve opposite. We just have to pick the trig function that will allow us to solve opposite. So if you look, I've highlighted the trig function sine. Because in the trig function sine, the sine of angle 30 will equal opposite divided by hypotenuse. So we'll go to the next slide to show you. So this is the formula. We know 30 degrees, so we plug in the reference angle here. And we know the hypotenuse, so we plug it in here. So we're left with one piece of unknown information, which is the opposite side. So just like any algebraic expression, we need to isolate the unknown. So we isolate it to one side. Sine of 30 degrees times 10, which is the hypotenuse, equals the opposite side. So therefore, sine 30 in your calculator, if you type sine 30 bracket 10 bracket equals, you will get 5. So I know that the opposite side has a value of 5 units. Okay. Okay, so let's solve angle 1. Okay, I think this is our last slide. So let's solve angle 1. The trig function is sine. It's sine because the reference angle, we see it. We know where the hypotenuse is, and we know that the 14 is opposite the reference angle. So therefore, we know that the trig function has to have opposite and it has to have hypotenuse. Therefore, we know it's sine. So the formula is sine of angle 1 equals opposite divided by hypotenuse, 14 divided by 20. And the solution, therefore, is sine of the angle equals 0.7. So if the questions that you have to answer in your book are just to, like last week, all you had to do is find the sine of angle 53, the sine of angle 21, blah, 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 right? And then you end up with a decimal. Okay, so if that's all it wants, great. Round it to the proper number of decimals and you're done. However, if it needs you to convert that decimal fraction into a decimal degree, then, and if you think you'll forget this, please write this down. So when you're solving an angle and you're given the ratio, you'll end up, so the ratio is a fraction, right? When you solve that fraction, you get a decimal fraction. To convert this decimal fraction into decimal degrees, while this is in your calculator, while it still says 0.7 in your calculator, hit the second function or the shift button in your calculator, and then hit sine. Why sine? Because that is the trig function that we know we have to use with opposite and hypotenuse in its ratio. Okay, so 14 divided by 20 equals 0.7. While that's in your calculator, hit second function or shift, sine, equals, and you'll get 44.427004 degrees. So what that does is it converts a decimal fraction into decimal degrees. Okay, so if we rounded that, 44.43 degrees. But if we need degrees minutes or degrees minutes and seconds, we'll do degrees and minutes first. To solve degrees and minutes, then write down the 44. The 44 is your whole degree, so write that down. And then just take the remainder, that 0.43, multiply it by 60, because there's 60 minutes in 1 degree, right? So if you multiply 0.43 by 60, it will give you the minutes. So I think it works out to be like 25.8 minutes. So you would round that up to 26. Okay, so this will be a good PowerPoint presentation for you to revert back to when it's time for you to do your homework or to do your tests. Okay, so what I'm going to do just for a moment is I'm just going to go on to our whiteboard for a second here. Okay, so what I want to do is I just want to take you through just a couple of examples of other unknowns here, solving other unknowns in triangles. So let's start with getting our, let's increase our zoom here. There we go. Okay, so if we okay, so this is our beautiful right angle triangle. Okay, so now who's all here right now? Ryan, you're here, and Miles and Alessandra. Is anyone else here right now?
No, I think it's just the 3 of us.
Okay. All right, well, we're going to keep this brief, okay? I'll give you guys 3 or 4 examples, and then Miles and Alessandra, if you guys want to bolt, you can. Ryan, you're welcome to as well, but if you'd like to stick around to get some further examples, I'd be happy to stay with you, okay? So let's do this. Let's call this 35 degrees. Okay, Alessandra, I'm just going to throw you to the wolves for 2 seconds. So, you probably don't like it, but I'm just going to ask you a question to see if you can answer it. So, Alessandra, this side here, what is it called based on our reference angle?
Opposite.
Yes, dear. Okay, opposite. Very good. Okay, so Miles, I'm not going to give this one to you. You know that. And
Yeah, give me a harder one.
yeah, I know. Okay, so reference angle right here, key to everything. As soon as you know it, Ryan, you know where the opposite, you know where the adjacent is, right? So let's do, just for example, this here. Okay, so if I want to solve the hypotenuse, this is side x. Okay, we're going to call it side x. What I know is I know that this is not scale, but I'm going to call this 51 degrees down here. Okay, so I have an angle, and let's say a 13-inch side here. All right, so Ryan, because I know you love this part of it, the reference angle is right here. So that means that this side is called what, Ryan?
Adjacent.
Okay. And what other information in the triangle do we have, or are we trying to solve, Ryan? What's the side called?
We just know about the right angle there.
We know about, yep. So what we're trying to solve though is what?
The opposite, and actually no, the hypotenuse.
Hypotenuse, right on. Okay, so because x is being identified as the unknown value here. So what we need, Ryan, is a formula that has hypotenuse and adjacent in it. So out of SOH, CAH, TOA, okay? A and H, adjacent hypotenuse. So what's our trig function, Ryan?
Cow.
You got it, right? Cosine, right? You got it though. Cosine of the angle equals adjacent over hypotenuse. This is, I told you guys last week, this is 90% of it. It is. Identify the triangle's components based on the reference angle. So therefore, cosine of 51 equals, what's the formula say? Adjacent divided by hypotenuse. Therefore, 13 divided by hypotenuse. And now I told you guys I showed you how to rewrite the formulas. I won't go through all those steps. I'll just jump to the next step. 13 divided by the cosine of 51 equals x. So now it's just punch it in your calculator, right? 13 divided by bracket cosine 51 bracket equals, and that'll give you the length of the hypotenuse. Okay, so I do have something I don't know if I can actually show you this. Let me see. Okay, I'll try and do this just on our canvas here. Let's imagine you're in the shop, and we know that Rob, he's got zero mercy. So let's we got 1, 2, 3, 4, 5, and you just have to believe me when I say that these circles are equally spaced. Okay, this is, you guys know what this is called? You know what this is a picture of? This is called a BHC, which is a bolt hole circle. A lot of times in machining, we have to create holes that are equally spaced around the periphery of a perceived circle, right? A bolt hole circle. So I want to place 5 holes equally spaced around this bolt hole circle. So how do I know where they're located? So if I basically I'm drawing this center line, and I'm telling you that this, I'm trying to draw on an angle here and it's just not working. This bolt hole circle, this is your y-axis. You know what? I'm gonna do you a huge favor. I'm just gonna draw it a little bit more clear, and I'm trying a new platform here to draw on. I'm gonna put these two here and here, and I'm gonna put this here and this here. I think this is gonna get me closer, but you guys must be just laughing your butts off right now. This is horrible. All right, try one more time. one more time, and then you're
Isn't
gonna
there
just.
like a circle tool you could use or something?
I don't. You'd think so. You'd think there'd be something like that. All right, put these two across from one another, and I'm gonna, yeah, screw it. Okay, yeah, I'm just gonna go back to what I had. All right, let's make it like that. Oh my gosh, I gotta stop doing this. I'm gonna just, come on. Okay, we're gonna put the crosshairs right here, and we're gonna put another one here, here, and here. Okay, so we'll make life sort of easy here. I'll put let's see, I'll put one hole here, one hole here. I won't worry about doing 5 holes. I'll just do something even so that we can get through this real quick. I can hear Miles bouncing up and down in her chair here. Okay. All right. So on this type of situation, we'll be given some information. We'll be given the size of the bolt hole circle. So let's say that it's 3 inches in diameter. That's this dotted line. That's the bolt hole circle. We'll also be given some information like, what do we have? 1, 2, 3, 4, 5, 6, 7, 8. So 8 holes equally spaced. Okay, on this 3-inch bolt hole circle. So if I'm going to apply trig to this, if I need to find out the location of all of these holes, I need to know a little bit more information. I need to know where the center of this bolt hole circle is relative to the part. So, if our part is just a square block, whatever, it doesn't matter. We can do this whatever way we want. But all you need to know is, right, either where the datum is or where the positioning of this part is. So let's say that we know that this bolt hole circle is 3 inches. Let's say that the distance from here to here is 2 inches. And we'll make it nice and easy and say it's also 2 inches from here to here. Okay, so we now know where the center of the bolt hole circle is, right? So what else do we know? Okay, so what we know is that there are 8 holes equally spaced around this bolt hole circle. So if I wanted to find the location of the center of this circle, I wanted to know the distance from the center to the center of this hole. I can easily find that because I know that this length is my radius. The length from the center of a circle to the outside of a circle is the radius, and we know that it has to be 1.5 inches because the diameter of the bolt hole circle is 3. Therefore, the distance of the radius is 1.5. Now, if I needed to find the location of the center of this circle, I need to create a triangle. So here's what's interesting is that the distance from the center of a circle from the center of the bolt hole circle to the center of one of the drilled holes on an axis is the radius, 1.5. The Y location, the vertical location, we know is at 2 inches. So if I wanted to solve, let's call this hole over here, let's call it position 1. If I wanted to solve position 1, I know that the x is 2 plus 1.5, right? So therefore is 3.5. The distance from here, right, from here to here, plus from here to here, which is directly below this point here. So I know the x position is 3.5. I know the y position is at 2. It's the distance from the datum down here to the middle of the block. So I know that the y position is 2. So I now have the location of one of those 8 holes. But if I want to solve the location of this second hole, we'll call position 2. I need to do some trig, because all I know is the radius, which is no longer this just a line. It's now the hypotenuse, right? 1.5 is the length of the hypotenuse in this right angle triangle. Well, we know in trig we need 3 pieces of information. Right now we have the length of a hypotenuse and we have 90 degrees. That's the only 2 things we know about this triangle. Now, I'll just throw it to you for a second. Is there anything else about this triangle we either know or that we can solve?
Yes, I think so.
And what's,
Because it has 8 circles, right? So on the I forget what they're called. The 2 black lines you have.
yeah, so your 2 axes, right? The center lines?
Yeah, your 2 axes, and you have a hole on each one, and then one directly in between it. So that's square, the 2. So halfway between it would be 45 degrees.
Right. Now, that's why I wanted to show you guys a 5-hole, but you're absolutely right. You're looking at this in quadrants now, right? You're looking at, in this upper quadrant, okay, which is up here, this upper quadrant, right? You've basically broken it up into 3 positions, right? You know that this is 90 degrees. Therefore, this is 90 degrees, half of it is 45. But if it was a 5-hole bolt hole circle, that doesn't work out. So tell me, what angle did you solve, Miles? What angle is it that you solved? Let's call this angle 1 or angle 2?
Angle 2.
Correct. So if you could, in this case, quickly identify angle 2, that it's 45 degrees, you know that this is the angle that would make most sense to solve, right? Because you understand that there's a location of this drilled hole in between this one, and it's based on how that angle increases, right? So if you solve this angle in the first place, I'm going to tell you, all of you right now, that that's the angle you want to solve. The easiest way to do that is you take 360 degrees, that's how many degrees are in this bolt hole circle, and divide it by the number of places, which is 8. And if you do that, you end up with 45 degrees, right? Which is exactly what Miles said, 45 degrees, right? So if that's 45 degrees and you have a 1.5 inch length and you have a 90 degree length, then you're able to solve the sides that you want. So what sides do I need to solve right now? Well, I need to solve, I'm going to just get rid of this for a moment because it's going to be in our way. I need to solve the distance between here and here. And I need to solve the distance between here and here. So I need to solve, let's start with Ryan telling me what side of the triangle, Ryan, is this right here. What side is this called? This is our reference angle. What side is this? Right here.
Oh, that was adjacent?
Yes, sir. Okay, so I need an adjacent side. So I have a hypotenuse, I have a reference angle, and I have adjacent, right? So we're back to cosine. Cosine of 45 equals, the trig formula is adjacent over hypotenuse. So it'll be the unknown, right? Adjacent divided by 1.5. So you would rewrite that as cosine 45 times 1.5. And if I'm not mistaken, I believe that's 75, but I can't see now, but cosine 45 times 1.5. Cosine 40. Okay, I'm wrong. Good. Well, it's good to be wrong once in a while. All right, so let's try it again just to make sure. Adjacent over hypotenuse, cosine 45 times 1.5 is 1.061 rounded. So 1.061 rounded. So this is our x-axis that we solved. So we could write over here position 2 is x. We know it's 1.061 plus 2 inches. So it's going to be 3.061. And what is our y position? So now we need to solve the opposite side. So we have a reference angle, opposite, and hypotenuse. So that's going to be sine, right? Because it's opposite and hypotenuse. 45 equals the opposite divided by 1.5. Now, if I'm not mistaken, this should be exactly the same answer because it's a 45-degree angle, right? So just to verify, we'll do sine 45 times 1.5, and it is in fact the same, which it should be. Okay, so therefore x will be 2 inches plus 1.061, so 3.061. So to use trig, practically speaking, we need to see the triangle. As soon as we see the triangle, we need to identify 3 pieces of information, right? Number 1, either a side and 2 angles, or number 2, an angle and 2 sides. But you need 3 pieces of information to be able to solve the other 3 pieces. And this is just one example of how to do that. So if, and then you got to look at symmetry as well. In this case, like, it would be silly to draw 2, 3, 4, 5, 6, 7, 8 triangles. Miles kind of gave a bit away there, maybe knowingly or unknowingly, but gave a little bit away there. She realized that there is one hole evenly spaced between a hole on the y-axis and a hole on the x-axis. That means that this quadrant 1, and just so you guys know for future, this is called quadrant 1, this is called quadrant 2, 3, and 4. Okay, so quadrant 1 is the mirror image of quadrant 2, right? About the y-axis. And quadrant 3 is the mirror image of quadrant 2 about the x-axis. And then quadrant 4 is the mirror image of quadrant 3 about the y-axis. So in other words, this triangle that we drew right here is the same triangle as here, right? Back to geometry. Therefore, we know that this line is a continuous line. And oh my gosh, look at this. We are drawing the reciprocal of the triangle. So it is the mirror image, right? So we really only need to draw one triangle. And then we can solve the rest of this information with 3 other triangles that we just know are the mirror image. The only difference is the direction of the movement. So I don't know if any of you have ever done any work in CNC programming or will be doing any programming in the near future, but a good thing to keep in your mind, this bolt hole circle that we just talked about, where I put the location of the bolt hole circle, if we called that 0, if we called this dead center location 0, that's our datum, then and we get rid of this, right? We say this is now our datum. Then quadrant 1 becomes an x positive, y positive location. All of your math, all of your locations, all of your solutions up here are all positive locations, right? So this hole, and this hole will all be positive locations. But this hole is on the left side of the datum. It's on the left side. So on a I don't know if you remember, back in public school, we were taught about a number line, right? You have 0 here and you have 5 units there, 5 units here. This is +1, +2, etc., etc. This is -1, -2, etc., etc. Everything on the right of the 0 is a positive number. Everything on the left is a negative number. So not only do the units matter, 2 units to the right is a positive direction, 2 units to the left is a negative direction. So the number matters, but so does the sign in front of the number. So for us in trig, the only reason I'm going over this is that when we start talking about the reciprocals of the trig functions, we're talking about the equality of the trig functions in another quadrant. Okay, so we start using negative values. And that's why I don't want to go into too much detail about it, right? And as we demonstrated up here in the top, this triangle up here, and this triangle here, and then this one here, and then the one that would be formed down here, right? They are reciprocals of each other. Some of the numbers in those triangles are positive directions, and some of them are negative directions. And that's how reciprocals of trig functions work, is it's based on where the triangle is on the Cartesian coordinate system, what quadrant it sits in. So again, advanced math, another time we'll get into that in a little bit more detail. But this kind of gives you a layout of how to use the trig. We're only going to work with sine, cosine, and tangent. We don't care about the sign in front of the number. All I want to do is draw a triangle and figure out what the length of the missing sides or the angle of the triangle is. The very, very last thing, should take about 2 minutes. One thing I want to remind you guys of last week, but I want to show you just so you don't forget. In triangles where we do not have a known angle, like we have 90 degrees here, but if I want to solve this angle and I have a 22-inch length here and I have a 29-inch length here, and I want to solve x, okay? What trig function am I going to use to solve x? So first things first, what is the reference angle, Ryan? What's the reference angle called?
What in this scenario? It's x.
Yes, sir. Good. X is our reference angle, right? Good. How do we know that? Because it's the angle we're trying to solve. It's what I just said is the unknown. I need to know what angle x is. Therefore, that's our reference angle. So these sides are determined by our reference angle. So this side, therefore, the 29-inch is our opposite, and our 22-inch is our adjacent. We don't know the hypotenuse. We don't care about the hypotenuse. Why? Because we have 3 pieces of information. We have a side, and an angle. I don't need to know the hypotenuse to solve x. I already have 3 pieces of information. It's time for me to move on. So I'm going to now solve x. I need a trig formula with opposite and adjacent. I know that's tan. Tan of the angle. I don't know it. I want to solve it. Tan of the angle equals opposite divided by adjacent. Next thing I'm going to do is I'm going to solve that ratio. 29 divided by
1.3 something. Actually, I have no idea.
so 29 divided by 22. So therefore tan x equals 1.318181818. Okay? All we've done right now, I want to know this angle. I want to know angle x. So what I know is the ratio. I know the opposite and I know the adjacent. And if I solve this ratio, I've changed nothing about this equal sign. This still equals this, right? They still equal one another. All I did was solve this side. So this still equals this. But this is only a decimal fraction. I need to convert it into an angle. So this is the part you need to remember. While this is still on your calculator, I need you to hit second function. And what's the trig function? Tan. So tan equals. And that will change your decimal fraction to 52. So tan x equals 52.81529.355. And if I want degrees and minutes, Then I write down the degrees, 52 degrees. And while it's on my calculator, right? Oops, sorry. While it's on my calculator, all I'm going to do is I'm just going to subtract the 52 degrees. And that's going to leave me with the decimal, right? The 0.8152935, or whatever it was. Maybe I wrote it down. But anyway, subtracted the 52, okay? And then I multiply that by 60. That number that you get next, that decimal number, just the whole number, the 48, is your minutes. Oops, there we go. Right? That's your minutes. So let's say I want to do minutes and seconds. So I'm going to write down the 48. Okay, so here I'll go 48 minutes. And now I want the seconds from this. Okay, so I'm going to subtract that 48 off my calculator. And that leaves me with this decimal. Now I multiply that by 60. And that will give me the seconds. 55.05 seconds. So if I round that, it'll be rounded to 55 seconds. So what I've discovered is that angle X is 29 divided by 22, which gives me this decimal fraction. Then I will use second function, or on your calculator it may say shift, and then I'm going to hit the second function button and I'm going to hit the tan button. And that will give me this, decimal degrees. Okay, decimal degrees. And if I subtract the 52 and write it down here and multiply the decimal by 60, I get 48 minutes. Write it down, then subtract it off your calculator, and whatever decimal is left there, multiply that by 60, and that'll give you the seconds. So that is the degrees, minutes, and seconds of angle X.